Thank you. So I'll be talking about rejecting the null hypothesis of apathetic retweeting of US politicians and the US Southern Poverty Law Center, or SPLC, defined hate groups in the 2016 US presidential election. So this is joint work with a lot of colleagues from social and political psychology in New Zealand and Canada, and several of my research students from Christchurch, New Zealand, as well as more recently from Uppsala's departments of mathematics and information technology. So here's the outline. We have questions and concerns about the experimental design. The second one is on data and statistics, how our experimental design of Twitter streams further augmented by retrospective REST API augmentation calls can be formalized as a statistical network designed experiment. And then we will get into mathematical models of what we mean by ideological retweet concurrence, and finally results. So the three basic questions we would like to ask is question one: is President Trump preferentially retweeted by various types of hate groups or their leadership relative to other politicians, that is Hillary Clinton, Bernie Sanders, Ted Cruz, and Paul Ryan, against the null random network model, so-called apathetic retweeting, which we will formalize shortly. Question two: what frequency of unique users retweeted both a politician and a hate group or its leadership more than expected under the null model? So these two are essentially hypothesis tests. Question three is more of an exploratory nature, where we explore the alternative space in a principled way. So this is about the joint distribution of the degrees of separation to each user from each of the 5 politicians and the 8 most prolific hateful ideologies on Twitter in terms of activity levels. That is measured through the lengths of the most retweeted directed paths in the observed network. We will formalize all of this with cartoons soon. Finally, question 4, did the US hate networks get help from the Russian trolls? Right? So this is essentially going back to basics in the big data age of scientific hypothesis testing from the early 1900s and Karl Popper's demarcation of science from non-science, where a scientific hypothesis is one that's falsifiable. What is a Twitterverse? It's a microblogging service. We have tweets, retweets, reply tweets, coded tweets, retweets of coded tweets, replies of retweets of coded tweets, and so on. All these classifiable interactions are termed status updates in Twitter. So a tweet can be retweeted. It can have tags, which are hashtags. A tweet can contain links to URLs or point to various sources. Tweets can mention other users. Users themselves post tweets and update their status, and users can follow one another. Okay. So what did we do? We used the freely available public streams in Twitter and the REST APIs and collected about 22 million status updates related to the 5 politicians and the 52 hate groups. And in our designs, we allowed for what we call retrospective REST-based network augmentations, which allowed us to fill in the gaps by going into the historical timelines of anyone we want to choose in order to make sure that the graph is fully connected up to some thresholds. So this is the US Southern Poverty Law Center, which gives us this publicly available database of so-called hate groups. I don't necessarily agree with SPLC or anyone else, but this is just interrogatable, and from a mathematical point of view, this is arbitrarily castable into any subset of the total set of user accounts in the population of interest and the population of concern. So these are called extremist files, and they're broken down by ideology, individuals, and groups. The SPLC's definition of a hate group is the following: it does not necessarily consider all groups or individuals on its extremist files as violent or engaged in criminal activities, but rather identifies any group or individual whose beliefs or practices attack or malign an entire class of people, typically for their immutable characteristics. Okay? So for example, this database does not contain foreign hate groups like Boko Haram or ISIS or Al-Qaeda or whatever the fashionable trends are. So here is our active hate group map that SPLC generated in 2016 before the election. So these are very specific hate events that are recorded and verified by different types of hate crimes. So hate groups are in 1991 to 2015, you can see the incidents, the number of hate incidents, sort of slightly peaking, and post 2016, it's a bigger spike. You can look at that data, it's publicly available. So we had 18 US hateful ideologies defined by the Southern Poverty Law Center. So these include alternative right, anti-immigrant, anti-LGBT, anti-Muslim, anti-government movement, black separatists, Christian identity, general hate, that's my favorite, Holocaust denial, Ku Klux Klan, neo-Confederate, neo-Nazi, Phineas priesthood, racist music, racist skinhead, racist, radical traditional Catholicism, sovereign citizens movement, and white nationalists. So this is just a screenshot from a Databricks shard that was running thanks to Databricks. It was done in partnership with the Databricks Academic Partners Program. So you can see the streaming statistics and the number of events. Status updates reached about 120 events per second in our streaming designer on the third US presidential debate day. And over the last 2 days around the election, you have a very serious spike in the mass media-induced explosions in Twitter. So the public streams of @RealDonaldTrump, @Hillary Clinton, @Bernie Sanders, @Ted Cruz, and @Speaker Ryan, and 52 SPLC-defined hate groups or the leaderships were defined as subsets of user accounts in our full monitored space. We also collected data that includes any mentions, replies, retweets, etc. of these Twitter accounts of interest for about 9 weeks around the 2016 US presidential election. 4 weeks before the election, 4 weeks after the election, and the week of the election itself. Beyond this, we looked at verified accounts as well as geolocated accounts and a random snapshot of non-geolocated accounts around the third US presidential debate, like a couple million accounts. And then we retrospectively augmented the data based on their historical timelines that intersected with the 9-week period. That's how we fought against certain graph properties we needed for downstream algorithms, and also make sure so we actually dropped down into the second and third orders for the status update networks. So here is the 12 SPLC-defined hateful ideologies, and you can see the number of followers vary quite a lot. Anti-government is quite high, and so are black separatists and alt-right and so on. And also SPLC changed the definition of alt-right in the middle of our experiments, so it's a bit complicated what alt-right really is. So yeah, that's kind of the breakdown of the followers. And if we look at the sort of network statistics, the retweet network statistics of the 5 political accounts, we have Donald Trump with in degree 40, which means that is the total number of retweets Donald Trump did. In neighborhood is 12, which is the number of unique people who Donald Trump retweeted. Out degree is the number of retweets of any original tweet by Donald Trump. And out neighborhood is the number of unique users that retweeted @real Donald Trump. And the same for Hillary, Bernie, and so on. So this is up to the proprietary algorithms in Twitter's free streaming REST API. So, it's a sample, and that's the breaks. If you notice, the out neighborhood of Hillary and Donald is roughly the same, which means the number of unique retweeters are roughly the same, but then you can see that the rate at which the unique retweeters of Trump retweet Trump is more than twice as high as that of the Hillary supporters, because they're passionate, I guess. So here is basically the breakdown by the type of tweet. So we did all the Spark SQL streaming jobs for this. So we classify, and you can question our classification. We categorize into retweets, reply tweets, original tweets, coded tweets, retweets of coded tweets, reply of coded tweets, and have a lot more categories. And so in summary, we have about 2.7 million tweets and 13.7 million retweets out of the 22 million odd status updates. And we limited our analysis to only tweets and retweets in order to not fall into the natural language understanding mess. So, and also retweets have very clear signal of directional concurrence. 4.4 million distinct retweet pairs were there, the original tweeter and the retweeter pairs, and 2.5 million unique users. So this is just kind of a data set overview. So we got into a pure math paper on the combinatorics of these processes called transmission processes, and associated with those transmission processes are transmission trees, which encode who transmitted to who, when, what, so that it can be potentially be produced as evidence in a court of law in terms of the particular EU laws on incitement to genocide. So the motivation, mathematical motivation for me is law. So we have this particular notebook you can dive into, and there is a larger program called the Meme Evolution Program. And the tools we use are just Spark SQL, where we just do future proofing against evolving Twitter schema by just essentially taking a Parquet single column JSON string of each status update, and then we sort of do a double read ingestion to make sure that all the schema, whatever it is consistently read in an interval of time of interest. We use graphics and limited ourselves to Pregel programming, bulk synchronous parallel programming, vertex programs, and we used various Spark MLlib standard algorithms, distributed linear algebra and standard stuff. And in Spark Core, we mainly use distributed sorts and joins. So this is kind of a little snapshot, sort of Trump-Clinton retweet network. Current post user screen name is on the left. Original post user screen name in retweet is @RealDonaldTrump. So we know this guy retweeted Trump, and the retweet itself is something about China is cooking up conspiracy theories or whatever. So you can read about this if you want. I mean, this was just a random seed 42 pull these. So then we can look at the retweet network weighted. So we can look at the original tweeter and a retweeter, and then count how many times they retweet that pair. That's just the weighted retweet network. It's just an aggregation operation. And this is kind of a D3 probe to visualize as we are writing stuff. So you can kind of look at tiny snapshots when you sample and interact in D3. And this one is just a community structure detection algorithm, the Louvain algorithm, which we had to bring down the CSV files and run it on Gephi just to get an idea. So on the third US presidential debate day, there were about 22,000 retweets, retweet network, and this is just the community structure. And 5% random sample on October 19, 2016. That's again the, you can see Louis Farrakhan and Tommy Lahren from Texas. I like Tommy. Does anyone know Tommy? All right. Oh yeah, good, from Dallas. So I have no philosophical affiliation to any ideological propagators. But the point is, this is a highly structured community, and it's continuously changing in time. So that's basically the data and the statistics of interest. So now we're going to move into a bit of mathematics. So this is an arc. Aij is 1. If I ideologically concurs with J, that just means I retweets J in this very limited setting. So that's just a retweet network with just 9 guys. And they could be in different communities or whatever. I just colored them just to show. Of course, there is a very, very large number of possible directed networks on 9 individuals, right? So it's a really big number. What we want is the in degree and out degree to be conditioned on the random networks that we will generate under the null hypothesis, because this is somehow going to control for the individual variation or heterogeneity in Twitter activity levels. So that's basically going to be our null hypothesis. So this is mathematics. It's called a random directed configuration model. And this is what we mean by our H sub 0, or the null hypothesis of apathetic retweet network. So this is a distribution on the space of networks such that every realization of this random graph model will produce a new random network that preserves the in and out degree in the observed network for every user. Is that clear? Right. We just basically preserve the total number of times someone retweets someone else, and the total number of times someone else gets retweeted. Except we don't care about who retweets who, so we're purely apathetic about who we retweet as long as we preserve the in and out degrees of the retweet network. And for this, we just need distributed computing using Apache Spark because we just have to sort at the end of the day and join maybe. So this is kind of what my collaborators were looking at one point. So we were just sort of looking at Trump cluster and Clinton cluster based on some community detection algorithm and saying a significant proportion of retweets by leaders of 7 extremist ideologies have original tweets in Trump's ideological cluster, which is shown in sort of this blue here, and orange is Hillary's cluster. And then everyone is like, oh my God, so many people from SPLC defined categories are retweeting Trump way more than Hillary. So. And of course, this is not correct because you saw the activity levels of Trump's retweeters are way more intense than that of Hillary. So it could just be because he has a much farther reach. And so you can also look at these plots. This is giving you the log base 2 of the number of retweets of an SPLC-defined hate group on the y-axis and log base 2 of the number of retweets of @real Donald Trump. So each dot is a user account, okay? And of course, there's a lot of activity for Trump, and Hillary, it's very minimal, very sparse. So this is not enough. You can also break it down by ideology, and once again, Trump dominates in every ideology, especially anti-immigrant and white nationalist and anti-Muslim and so on, and Hillary is again quite sparse. Of course, showing these plots is not going to cut it, and then they were trying to do chi-square tests. Once again, chi-square tests, the significance is very high, but these tests do not account for the network heterogeneity. So they're sort of stopped at reviewer cycles in academic journals in some fields. Now we're looking at a bit more robust statistic. We're restricting to retweeters who retweet at least 4 times one of the hateful ideologies and one of the presidential candidates. So these are much more robust signal, at least 4 times in the 9-week period, which is roughly once a fortnight at least. And once again, the p-value is significant, but the chi-square test is not applicable. So here is our sort of little mathy solution. So we use this cut, permute, and rewire algorithm. This is the directed edge, retweet edge representation in the 2 columns. So you have a tweeter and a retweeter as users in colored nodes, and a retweet is an edge. And that's the multi-edge self-looped representation of the exact same retweet network. So what is this? We basically want to sample. So we first cut these edges into 2 half edges. We simply permute it, right? I've just taken 1, 2, 3, 4, 5, 6, 7 in this ordering. 1, 2, 3, 4, and I flipped it 1, 2, 3, 4. So we go through this permutation just to make it easy. So of course, there's a lot of 9 factorial permutations here. So I permute it, and then I crosswire. I just connect it, rewire. So that final network is a sample. So this is the original network, and now we have an algorithm that can produce a sample network from this apathetic model, apathetic retweet network model. And if you notice the sample network, every node in the sample network has the same number of in and out edges as that of the original network. So what is the probability of the sample network? Sort of a math question. I only have 4.5 minutes left. I'll tell you the answer. So it's 1 over the number of edges factorial, which is 1 over 7 factorial. It's 1 over 50, 40. So they have a uniform distribution. Every sample network has a uniform distribution. So now what you can do is you can take any test statistic of interest, apply it to each realization, and get the null distribution of the test statistic, take our observed statistic, and see if it is an extreme tail of this null distribution. That's called the generalized Fisher's exact test. Goes back to 1930s Fisher, right? So this is just the pseudocode of the algorithm. And the interpretation is that the independent and identical samples from this retweet apathetic network model are all we need to be able to do any test statistic, which is just a projection of that network. So finally, this is not reality, folks. President Trump would say otherwise, because this is called falsifiable hypothesis testing. So even if you reject the null hypothesis, it's just that the hypothesis has withstood an attempt at its falsification, right? So science proceeds like that. So now to probe into the alternative space, we go into an empirical geometric retweet network, and we use the most retweeted directed paths. So what's the idea? The idea is simple. So we have a weighted, first we have our standard multi-edge self-loop retweet network. Then we turn into a weighted retweet network, just count the number of edges. And then finally, we take each weight and transform it by 1 over 1 plus the number of retweets. So this is a geometric retweet network. And there's a nice relationship between Poisson exponential and the geometric random variables. So in a geometric retweet network, the shortest directed path from A to B is the most retweeted path, like the most noisiest path in terms of number of retweets. So now we can use distributed Dijkstra's shortest path algorithm. This is all just standard undergrad stuff. So now let's take our little thing here with a bunch of retweets, geometrically weighted, and let's say this is embedded in a population of interest. And so we are going to now say everyone retweets everyone else just once. So it's 1 over 1 plus 1, which is 1 over 2. Right? So this is what we have, the population's geometric retweet network. And now comes along 2 particular landmarks of concern. So in the population of interest with the landmarks of concern, we can construct what will be called ideological trees in the next minute. So in this landmark, we have 2 user accounts, landmark 1. In this landmark, it contains only 1 user account. So then suppose we consider some arbitrary user X, and we are interested in the shortest weighted directed path length from that user to one of the landmarks. So here, the shortest weighted directed path length from X to L1 is 3, because we have to go 1, 2, 3. And for the other guy, we can go directly. So that's how we can define the shortest weighted path length to each landmark. And the same way for this other guy, right? So now this gives us Manhattan distances between these landmarks, distances to landmarks. So this will be, so the Manhattan distance between plus and star in this landmark notion of ideological diversity is just 3 minus 4, absolute value plus 1 minus 3, okay, which is 2. So I'm going to skip this in the next 45 seconds. So the fundamental thing is we can ask this sort of where am I operator problem. So I, as a Twitter user, can ask where am I on this ideological tree? Which leaf node am I? Which clade do I fall in? How is this clade changing in time, and so on. So we're doing this for meme evolution program Sverige in Sweden, where we're monitoring the entire Swedish Twitterverse. So this is an example of an ideological tree. So we have sort of various clades. There's a red clade, a blue clade, and a purple clade. And each leaf node here has an ID. So actually, this is a node. And there are lots of user accounts below that. So I'm just showing you the very top of the tree. So if you sort of zoom into the tree, you're going to see, for example, this node, ID 5, has 42,853 users, which is about 2% of the population. And they're 1 degree of separation, retweet separation to Trump, 1 to Clinton, and so on, and to all these hateful groups. For example, here is an interesting clade, which is about 4,011 users, about 0.1% of the population. And they have 1 retweet degree of separation to anti-immigrant group and 1 to Trump. And if you descend further into these trees, you can see the ideological diversity of different kinds of hate and which is within 1 or 2 degrees of Trump. So we basically did some tests now. And so in this particular test, we looked at the relative frequency of retweets by any one of the hate groups or the leadership for any original tweet made by one of the politicians. So about 0.987% of the retweets by one of the hate groups was made for original tweet by Trump. So you should see these 5 numbers, 0.987, 0, 0, 0, 0.013, as an ordered quintuplet in the simplex, in the probability simplex numbers that sum to 1. So, and then what these brackets are showing you is the distribution of the acceptance region, the marginal interval of the null acceptance region, by applying the same statistic to every realization of our retweet network. So clearly this falls way above the null expectation, which is if people retweeted at random, preserving everyone's activity levels, they would only retweet Trump about 60% of the time. And for Hillary and Bernie, it's a lot less to the left of it, right? So, and this is the other more interesting one. This is the number of unique users who retweeted a politician and a hate group at least 5 times each. So this is what I'm showing. And once again, real Donald Trump dominates here. This is the number of unique users who retweeted a politician, say Trump, and one of these ideologies at least 5 times each. So of course, for black separatists, it's an interesting story. And once again, we can do the exact test, generalized Fisher's exact test, except each one of these numbers, like 107, 3, 0, and so on, this is one long vector that lies in a very high dimensional space. It's a test statistic. And what I'm plotting here in these brackets are the marginal acceptance intervals for each of those numbers. And if there's an asterisk, it means these are the users who lie above the acceptance region, so they preferentially retweeted Trump, anti-immigrant and anti-immigrant ideology, much more than you would expect by chance. And if it's a circle, it means they preferentially avoided retweeting Hillary, and while they retweeted an anti-immigrant group, because it's below that. Right? So the main thing to notice is black separatists are all preferentially not retweeting. They all have the circles underneath, so they're all below the E. Okay? So then this is just one, then you can make sense of this ideological tree already described. This is just zooming much closer into what's happening at the very tips of the tree when we descend into the user accounts for different ideologies. So anyway, here is a significant statement, and I think I'll stop here.
You finished the last part?
Yeah, so basically, yeah, so that's the significant statement, right? So on a seemingly highly hopeful note about the American people, only a small fraction of those within 3 degrees of separation from @real Donald Trump during the 9-week period are also within 3 degrees of separation of any hateful ideology. So it's a more subtle story. And Russian trolls, I don't think so. I mean, even if they were operating, they won't target these guys, right? These are already converts. They'd operate on those guys that are on the fence. We did the same for UK election and had to introduce random ideological forests. What's happening in MEP now? We would like to get more into structured streaming. Please contribute, and it's funded by a lot of agencies around the world. Thank you.